Hello and welcome to today's lecture on multimedia networks. Multimedia communication is considered to be the holy grail of data communication. No lecture series or course on data communication is complete without a discussion on multimedia communication. I shall cover the various aspects of multimedia communication in 3 lectures, and this is the first lecture on multimedia communication. And in this lecture I shall cover the following topics. First, I shall give an introduction about mentioning what is multimedia. Then we shall consider how audio and video, which are the 2 important multimedia which can be digitized. Then the bandwidth requirements after digitization. Then we shall discuss the multimedia transmission requirements and SAS factors for audio and video. And based on this, the network performance parameters required for transmission of multimedia will be discussed, and we shall explore the possibility of multimedia communication through different types of networks such as circuit switch networks, packet switch networks, local area networks and internet. And as we shall see, there are many limitations and we have to overcome them by adding some functionalities or protocols such as RTP, RSVP and MBON, which I shall cover in this lecture. On completion, the student will be able to define multimedia, that means what do you really mean by multimedia. They will be able to explain how audio and video signals can be digitized and what are their bandwidths. They will be able to explain the SAS factors. I shall go into the details of this for audio and video transmission, and they will be able to state the network performance required for multimedia transmission, and then they will be able to explain the limitations of multimedia transmission through different types of networks as I mentioned. Now, let us come to the definition of multimedia. Multimedia stands for more than one continuous media such as text, graphics, audio, video and animation. In this context, this presentation that I am making can be considered as multimedia presentation, because I am using text, I am using graphics, I am using animation. However, commonly when 2 or more continuous media are displayed during some well defined time with user interaction is considered to be multimedia, and the most demanding of them are audio and video. So, we shall primarily focus on audio and video, although text, graphics, animation are also considered as multimedia, part of multimedia. What do you mean by audio? By audio we mean what we hear through our ears. Video is what we see through our eyes. So, let us now see how we can get the digitized audio signal, because we have to communicate through computer network which is digital in nature in most of the situations now, and as a consequence the analog audio signals are to be digitized. First, let us briefly consider how it is being done. As you know, the sound waves are converted to electronic form using microphone. Microphone is used to convert that sound waves in air to electronic form. then that is obviously is analog in nature. That analog signal is converted into digital form by using several steps. First thing to be done is sampling. So, you have to do the sampling of the analog signal based on Nyquist criteria, and we get what is known as PAM, pulse amplitude modulated signal, which we have already discussed earlier. Then a step is performed which is known as quantization. Quantization is performed with the help of analog to digital converter, and we get a digital output in terms of zeros and ones. So, here it gives you how it is being done for a sine wave. Here is the sine wave. So, this sine wave is sampled, and sampling frequency is has to be twice the maximum frequency, that means 2 f max. F max is the maximum frequency of the signal, and after sampling here it is quantized, because you have to represent the digital value by using some discrete numbers, and then these are converted into digital form by analog to digital converter. And by doing that, let us assume we are considering voice, and since the voice frequency is the frequency component remains up to 4 kilohertz, we can convert it to digital form by sampling at 8 kilohertz. So, when we sample at 8 kilohertz and we use a 7-bit analog to digital converter, the bandwidth required for communication of this digital voice is 56 kilobit per second. On the other hand, using sampling frequency of 8 kilohertz and a resolution of 8 bit, that means ADC has the resolution of 8 bit, we get a bandwidth of 64 kilobits per second. Whenever we have to record music on CD, the higher sampling frequency has to be used, because as you know, a music can have frequency components as high as 20 kilohertz, that is the maximum limit of our ear. So, as a consequence, the sampling frequency is 44.1 kilohertz, and the resolution, if you use 16 bit, then it gives you 1.411 megabits per second. We see the quite high data rate is generated. And of course, whenever we record in CD, usually it is stereophonic, so there are 2 channels. In case of voice, it can be single channel. That is why the data rate you have to multiply by 2 to get 1.411 megabits per second. And normally, as we shall see, this uncompressed data for both for audio and video, later on we shall consider video, has got higher bandwidth. So, some compression is used so that it can be efficiently communicated through the transmission media or the network. And in this case, for example, whenever you compress voice, that 64 kilobits per second bandwidth becomes 4 to 32 kilobits per second kbps, depending on the compression technique used and the nature of the voice. And similarly, the CD data, whenever it is compressed, you can from 1.411 megabits, it comes down to 64 to 192 kilobits per second. So, which can be transmitted at a much lower cost. So, compression is indispensable, as we shall see, not only for audio, particularly for video it is more important. Now, let us focus on video. Best way to understand electronic video signal is to understand how we get a picture from a digital camera. All of us are nowadays familiar with digital camera, and a digital camera has got a electronic sensors, that is called charge coupled devices, which is nothing but some semiconductor sensor, which converts different levels of light to electronic signals of different amplitude. So, the light intensity is converted into some electrical signal of different amplitude. If it is color, then the light is passed through an RGB filter, as it is shown here, and then the 3 different components, red, frequency and green. So, you get 3 different components from the same video. For example, here you have got an image. So, here you have got an image. This image can be converted into digital form, and whenever we consider video, it can be considered as a sequence of frames. For example, this is one frame, this is another frame, and when these frames are displayed fast enough to get the impression of, we get the impression of motion. As you know, we use the retentivity property of our eyes. Whenever the frames are flashed on the eye at the rate of say 50 frames per second, we do not identify the changes. That means it becomes continuous to us. So, that is why to get flicker free display, the frames are repeated 50 times per second. So, that is how we get video. So, essentially multiple video per second, multiple frames per second. So, how do you digitize it? What is being done? Each frame, which is an image, is divided into small grids called pixels, and for black and white TV, gray level of each pixel is represented by 8 bit. So, if you represent by 8 bit, that can be for each pixel will give you 8 bit data. In case of color, each pixel is represented by 24 bits. So, 8 bit for each primary colors, 8 bit for red, 8 bit for green, and 8 bit for blue components. So, in that case, for each pixel you will require 24 bits. For example, let us assume a frame is made of 640 by 480 pixels, which is essentially used for our for in case of your CD, storing the pictures in CD, I mean video signals in CD. And the bandwidth requirement for this is 2 into 25 into 640 into 480 into 24. Actually, it is repeated 25 frames per second 2 times, and these are the number of pixels, and here is the number of bits per pixel, and that gives you 368.64 megabits per second. So, you see quite high data rate is necessary, and this is too high for transmission without compression through internet. So, compression is a must, particularly for video. So, here an example is given. So, this is a frame and it is divided into 640 by 480 pixels, and that you get from a video digital camera. For example, a 3.1 megapixel digital camera provides the following resolution. In the highest resolution you get 2048 into 1536 pixel, that means in this direction 2048, and in this direction you get, in the y direction you get 1536, and if you want lower resolutions, then it can be 1600 into 1200 or 1024 into 768, or it can be 640 into 480. Now, for different applications we want different resolutions. For example, for high density TV, HD TV, the number of pixels required is, for horizontal it is 1920, for vertical it is 1080, and using 24 bit for as the resolution and 60 frames per second, that gives you 2986 megabits per second. So, it is quite high, and it cannot be sent by using most of the networks. For our standard TV, you require 720 into 576 pixels, and for each pixel giving 24 bits and 25 frames per second gives you 249 megabits per second. That too is quite high. For VCR, it is 640 into 480, and again by using 24 bits and with 25 frames per second you get 184.32 megabits per second. And there are two other standards which are CIF and QCIF, which are primarily used for video conferencing. There the data rates are small, I mean the pixel number of pixels used is smaller for lesser bandwidth. For it is for CIF it is 352 into 288, and 8 bit is used for giving the resolution, and 15 frames per second gives you 12.156 megabits per second. and for QCIF for low resolution multimedia video conferencing 176 into 144, that is the frame, and 8 bit per pixel and 10 bits for 10 frames per second gives you 2 megabits per second. So, you see it varies from about 3000 megabits per second to 2 megabits per second for different applications. So, this requires compression, and with compression it gets converted to you can see 2986 megabits per second gets converted to 25 to 34 megabits per second. This can be transmitted through many computer networks that we have already discussed using MPEG-3. That is a compression technique which we shall discuss later. Then your TV quality signals which requires in 249 megabits per second in uncompressed form gets converted to 3 to 6 megabits per second by using MPEG-2 technique, and VCR quality signal requiring 184.3 megabits per second in uncompressed form can be converted to 1.5 megabits per second by using MPEG-1. So, you can see it is the bandwidth required is greatly reduced, and CIF, for CIF you can use H.261 compression technique to give you a data rate of 112 kilobits per second, and for QCIF by using MPEG-4 you can generate less than 64 kilobits per second data rate. So, you see after compression the bandwidth is becoming much smaller, which can be communicated through many many networks that we have already discussed. Now, let us look at the qualitative requirements needed for multimedia transmission. For identifying the qualitative requirements, two things are necessary. First one is the response of the human ear. What is the frequency range? As you know, our ear can hear from 20 hertz to 20 kilohertz. That is the range of frequencies our ear can hear. Of course, for dog and other animals it can be higher frequencies. And one important property of our ear is it is sensitive, more sensitive to changes of the signal levels rather than the absolute values. That means the absolute values are not that important, the changes are more important. So, it is more sensitive to changes rather than the absolute values. So, this characteristic of the ear has to be utilized or exploited when we do multimedia transmission. Similarly, whenever we look at the response of the human eye, we have to utilize the property of our eyes. As we know, as I have already informed, whenever some image is flashed on the eye, it retains that information for few milliseconds before it dies down. That is called the retentivity of the eye, and that can be exploited for compression and essentially and later on for communication. Then there are some tolerance of error. There will be some error will take place as you communicate through some network, and particularly higher error rate tolerance is there for uncompressed signal, and whenever it is compressed, then the tolerance of error, I mean it is less tolerant to error. Later on, as we discuss the compression techniques in the next lecture, it will be evident why whenever an error occurs, it is less tolerant for compressed and it is not that much tolerant for uncompressed signals. And tolerance to delay and variation in delay, here also as we shall see, there is small tolerance for live applications. So, whenever it is not live application, then we can tolerate larger delay and variation in delay. And possibly the most critical aspect is the lip synchronization. Normally voice and video, these two are recorded separately, compressed separately, transmitted separately, but it is necessary to have synchronization so that there is lip synchronization. When somebody is singing, then lip synchronization has to be done with the audio. If it is not there, it will look very odd. That is why this lip synchronization is a most critical aspect for multimedia communication. So, the audio and video signals are to be synchronized. Later on we shall see how it is being done. Now, the requirements, the performance parameter for multimedia communication is expressed in terms of a parameter known as synchronization accuracy specification factor, SS factor, and this SS factor is specified with the help of 4 parameters, and essentially it specifies the goodness of synchronization. As I was telling, multimedia is essentially 2 continuous streams of data is coming, one for audio, another for video, then it is to be synchronized, and how good is the synchronization is possible, that is being expressed with the help of these SS factors, which is represented by 4 parameters. One is delay. So, delay is essentially the acceptable time gap between transmission and reception. So, as the here you have got a transmitter, it is passing through a network and it is going to the receiver. This is your receiver, this is your transmitter, and obviously there will be some delay depending on the communication media. If it is satellite, it will require, it will have long delay. If it is local area network, the delay will be very small. So, depending on the network, the delay will vary. Second important parameter is delay jitter. Delay jitter is essentially the instantaneous difference between the desired presentation times and the actual presentation time of the streamed multimedia objects. Let us see with the help of this diagram. So, suppose these are the presentation times for different multimedia objects. Now, because of the variation of delay, it may reach here, or it may reach here, or it may reach somewhere here, or it may reach here. So, at different points with respect to the original or actual presentation times. So, this is called the delay jitter. So, delay jitter represents the variation in delay, that instantaneous difference between the desired presentation times and the actual presentation time of the streamed multimedia objects. On the other hand, the delay skew is the average difference between the desired and the actual presentation time. It gives you the average value. For example, here possibly after immediately after synchronization it reaches here, then it reaches little earlier, a little later, or here it reaches still little later, here it reaches still little later, here it reaches still little later, and so on. That means the skew, the difference is increasing, the average value is increasing with time. So, in this direction you have got your time. So, this is being explained by the delay skew. This parameter specifies the delay Q. Fourth parameter is the error rate. The digital signal that is goes through the transmission media or the network, some error is committed, that is represented by the bit error rate. That means the number of bits in error, and total number of bits. That gives you the bit error rate. So, with the help of these 4 parameters, the performance I mean the synchronization accuracy specification is specified. Now, let us consider it in case of audio. In case of audio, the particularly for conversation, one way delay should be 100 to 500 millisecond range. It should not be more than this, which requires echo cancellation. Then the delay jitter has to be 10 times better than the delay. For example, if the delay is 100 millisecond, then the delay jitter should be less than 10 millisecond. So, it should be 10 times better than the delay. Then lip synchronization should be better than 80 millisecond. That means the time gap between the audio objects and the video objects should be less than 80 millisecond. and bit error rate should be less than 0.01 for telephone, that is voice, less than 0.001 for uncompressed CD, for less than 0.0001 for compressed CD. So, you see the requirement, that error rate, bit error rate requirement is more for compressed CD than the uncompressed CD. The reason I shall explain as I shall discuss the compression techniques in the next lecture. Now, let us look at the SS factors for video. For video, the delay and jitter requirement is less than 50 milliseconds for HD TV, high density TV, less than 100 millisecond for broadcast quality TV, and less than 500 millisecond for video conference. And error rate is less than 0.000001 for HD TV, less than 0.00001 for broadcast TV, and less than 0.0001 for video conference. So, for HD TV, the bit error rate requirement is more stringent than the video conference. Now, let us focus on the traffic characterization parameters. Traffic characterization parameter arises because of the variability of the bit rates. It is divided into two categories. One is constant bit rate applications, for example, uncompressed digitized voice transmission. Whenever voice is transmitted or video is transmitted in uncompressed form, it gives you a constant bit rate, that is being explained by constant bit rate. On the other hand, whenever audio or video is compressed, different parts of the video or different parts of the audio will not be compressed by the same amount. The compression ratio will not be same of different parts of the audio or video. As a consequence, it will generate variable bit rate. So, video transmission using compression leads to variable bit rate, and particularly you will see that most multimedia applications generate VBR traffic, that means variable bit rate traffic, and this variable bit rate traffic is the cause for burstiness in the traffic, and this burstiness ratio is expressed as the ratio of mean bit rate by the peak bit rate, that means the mean bit rate, which is the average bit rate, and by the peak bit rate. So, this ratio gives you the burstiness of a particular application. Now, having discussed the parameters required for multimedia transmission, now let us focus on to the networks. And the performance of networks are specified with the help of network performance parameters or NPPs. And there are four, again here you have got four parameters. First one is a throughput. Throughput is the effective rate of transmission of information bits. For example, Ethernet has the data rate of 10 megabits per second, 10 Mbps, 10 megabits per second. However, although the data rate is 10 megabits per second, the throughput is much less. It can be 3 megabits per second. You may be asking why. The reason for that is in Ethernet, as you know, there may be collision, and because of collision there will be retransmission or delay in transmission. So, because of all these things, the overall throughput, the rate at which the data will be delivered is much less than 10 megabits per second. So, that is why throughput can be lesser than the data rates. Then comes the delay. Delay is the time required for a bit to traverse through the network. It is essentially the end-to-end delay. As I explained, end-to-end delay is important, and depending on the network you are using, it can be different. For example, for satellite communication, the round trip delay, as you know, is quarter of a second. For LAN it will be very small, and for other wider networks it will be less than 1/4 of a second, but definitely it will be much higher than the local area networks. And maximum that can be tolerated is 250 millisecond, that is the maximum network performance parameter that is specified, and delay variance, that is a variation of delay as a packet traverses through the network, and this can happen because of various reasons. As you know, whenever an application is sending data, it has to be packetized, then there will be transmission time, there will be propagation time. There are three factors: packetization, transmission time and propagation time, and because of these three parameters and their variations, in some cases it will be store and forward type, and because of all these things there will be delay variance, and this variation of delay is expressed as the delay variance, and it should be maximum, it should have maximum value of 10 millisecond. Then error rate is specified in various ways. First one is bit error rate, which I explained, then packet error rate, which is the number of packets in error per unit time, and bit error rate is essentially number of bits in error per unit time, and packet loss rate is the number of packet lost per unit time, and cell loss rate is the number of cells lost per unit time. So, depending on the network, it can be packets, it can be cells. For example, for ATM it will be number of cells sent per unit time, and number of cells in error is expressed as cell error rate. Now, these values of network performance parameter as compared to the bandwidth and SS factors. So, bandwidth and SS factors of the application of multimedia transmission has to be compared with the values of the network performance parameter to determine the QA, quality of service of the network. So, quality of service of the network will be determined by comparing these two. So, quality of service has to be identified, and better the quality of service, good is the network. Let us now consider different types of networks and see how capable they are in for multimedia communication. First, we shall focus on circuit switch networks. We have already discussed different types of circuit switch networks. The first one and the most popular one is the public switch telephone network, or PSTN. We have already come out of the era of plain old telephone service, which was analog. Now, in most of the places it has been replaced by digital. That is why I am telling PSTN, public switch telephone network, which gives you data rate of 64 kilobit per second. But this is definitely not enough. This bandwidth data rate is not enough for real time video. So, this is excluded for video, for multimedia communications. However, we have seen that by that ADSL is the broadband service based on the public switch network that can give a bandwidth data rate of 1.544 megabits per second to 6.1 megabits per second over a small distance. So, this can be used for video on demand. We shall discuss about this application, video on demand, in detail later on, and also for internet access at home. So, this ADSL, which is based on PSTN, can be used for multimedia communication. Then comes the ISDN. ISDN has got two different interfaces, BRI, basic rate interface, and primary rate interface, giving the data rate of 144 to 192 kilobits per second or 1.544 megabits per second respectively. And this BRI is suitable for, this interface is suitable for digital voice and video conference, and PRI is suitable for compressed VCR quality video. We have not discussed ISDN, so let me very quickly go through the ISDN, give you an overview of ISDN before we come to other circuit switch networks. ISDN was developed in 1980s to allow the digital transmission of audio, video and text over existing telephone network. So, basic idea was to convert into digital form instead of keeping it analog, and it used common multiple channels in interleaved manner by using time division multiplexing. There were 4 popular types of channels. First one is A type, which is 4 kilohertz analog telephone channel, B type 64 kilohertz digital PCM channel for voice and video, C type 8 or 16 kilobits per second digital channel, then D type 16 kilobits per second digital channel for signaling. This is primarily used for out of band signaling, which we have discussed in detail. Now, as I mentioned, there are 3 basic types of interfaces, of which 2 are more popular. Basic rate, it gives you 2 B type and 1 D type. So, these 2 are interleaved, the 3 channels are interleaved, and primary rate, in primary rate 23 B type and 1 D type are interleaved together, and in hybrid 1 A and 1 C, 1 A and 1 C, these 2 are interleaved together. So, this hybrid one can be considered as a replacement of this that pure and old telephone system, that is your analog one. So, here it gives you the 2 types of interfaces. This is your BRI, basic rate interface, which are primarily used for home and small business houses. Here as I mentioned, 2 B type 64 kilobits and 1 D type 16 kilobits, these are provided. Of course, there is some overhead 48 kilobits per second with total band data rate of 192 kilobits per second, and this will require one network interface at the home, and from the network interface it goes to the ISDN office or ISDN exchange, telephone exchange. And the PRI one was developed for little bigger business houses, which gives you 23 B channels and 1 D channel of 16 kilobits per second, and these 2 together gives you a all these together gives you a data rate of 1.544 megabits per second, and which can give you many advantages and multimedia transmission. And this will require 2 interfaces, NT2 and NT1. NT1 is the same kind of interface as it is used in BRI. It is essentially you can say the interface which goes to the ISDN exchange, and NT2 can be a PBX, with the help of which it will do some kind of demultiplexing to a number of places. So, these 2 are necessary for interfacing to ISDN exchange. Now, let us go back to our previous slide. So, here we see that with the help of the PRI you can get compressed VCR quality video. You cannot have the TV quality video, but compressed VCR quality video transmission is possible by using PRI. Then you have got lease lines, which I explained earlier, having data rates varying from 384 kilobits per second to 274 megabits per second for fractional TI to T1, T1, T2, T3 and T4, giving you different types of capabilities starting from video conferencing, VCR quality video, broadcast quality video and HDTV for different types of lease lines. Then we have already discussed SONET, which is based on optical communication, giving you bandwidth data rate varying from 51.84 to 2844 megabits per second, and it is available in multiples of 51.84 megabits per second, and definitely it is very suitable for multimedia traffic. Now, the circuit switch networks gives you very good quality of service capability because of circuit switch services is excellent because of end-to-end connectivity. So, a circuit is set up, and after the circuit is set up, you know that whatever delay is there, that is constant. So, delayed jitter is not present. So, a digital pipe is available and continuously data is available. As a result, the quality of service is very good for the circuit switch networks. Now, let us focus on the public switch networks. As we discussed, the public switch networks has got two options. One is that virtual circuit type, another is datagram service type. So, in case of virtual circuit type, as we know, it establishes a end-to-end connectivity before data communication, and all the data goes through the same path or same route, which is not true in datagram service. As a result, there is no end-to-end connectivity. Obviously, in terms of quality of service, the VC based connection is better than the datagram based connection. So, for multimedia communication, we shall prefer this virtual circuit based public switch network, packet switch network, than this datagram type connectivity, because it gives you better quality of service. And here are the examples of packet switch networks. We have already discussed X.21, which gives you data rate of 64 kilobits per second. Obviously, it is not suitable either for audio or video traffic. On the other hand, frame relay, which gives you data rate of 56 kilobits per second to 1.544 megabits per second, is better than X.25. So, for some applications this can be used. On the other hand, SMDS, which gives you much higher data rate, 1.544 megabits per second to 46 megabits per second, can carry multimedia traffic. So, let me very briefly consider why X.25 is not suitable, because it gives you error detection and correction over every hop. As a consequence, it involves lot of overhead and delay, and since the bandwidth, as I said in the beginning, it is 64 kilobits per second, but nowadays higher bandwidths are also available, but those limitations are still there, and it cannot do bandwidth reservation, it cannot do multicasting, which is very important in case of multimedia communication. So, multimedia communication cannot run on X.25, as I said. For frame relay, again there is no end-to-end error and flow control. As a consequence, it is better suited for multimedia communication, having higher bandwidth. So, it may carry multimedia depending upon the detailed specification of the multimedia application. Now, I mentioned about that SMDS, which is switched multi-megabyte data service. Unlike X.25 and frame relay, SMDS is connectionless. So, as a consequence, because of this it is connectionless, it can be used for multimedia traffic, but it is not designed to provide quality of service. However, it gives you good smaller delays, less than 10 millisecond and so on. So, it can be used for multimedia traffic. Now, let us focus on the local area networks. We have already discussed various types of local area networks, and here is the summary. First one and the most popular one is the Ethernet, which has the speed of 10 megabits per second, but as I said, the throughput is much smaller than the actual speed. So, throughput can vary from 3 to 9 megabits per second, and obviously it is not suitable for multimedia because of non-deterministic nature of traffic. A particular packet may suffer a large number of collisions, and not only that, a particular packet or frame may get discarded. If it suffers a large number of collisions, there is a possibility that a packet will not be delivered. So, as a consequence, Ethernet is not really suitable for multimedia traffic. On the other hand, switched Ethernet, which gives you speed of 10 megabits per second, but it has much higher throughput because of that the bandwidth is not shared in this case. As a result, it gives you higher throughput, and it is suitable for stored multimedia communication. We shall discuss about the different types of multimedia application: stored multimedia, live multimedia, and interactive multimedia. Later on we shall discuss about it. So, this is suitable for this type of applications. Then comes the fast Ethernet, which gives you speed of 100 megabits per second, and throughput in the range of 40 to 90 megabits per second. So, it is suitable for both stored and live multimedia. And nowadays you know that most of the LANs are having gigabit Ethernet backbone along with the fast Ethernet distribution system. So, in a hierarchical system, your that backbone network is by gigabit Ethernet, and other parts at the lower level you have got fast Ethernet networks. In such cases, this the multimedia, live multimedia communication is possible in such type of local area networks. So far as the older rings are concerned, the token ring with speed of 4 megabits per second and throughput of 3.8 megabits second is not suitable. Token ring with 16 megabits per second data rate or speed having throughput of 15.5 megabits per second can be used for audio and video communication. FDDI2 with 6.144 megabits per second can be used for constant bitrate broadcast TV, and ATM, which is based on BISDN, broadband ISDN, is very suitable for multimedia traffic, and it is actually designed for multimedia traffic. It is based on circuit switching concept, and it gives you a speed of 34 to 155 megabits per second. As a consequence, ATM is very suitable for multimedia communication. Now, let us focus on multimedia over network, which is the most popular and important. Unfortunately, like many other technologies, the internet was not designed to carry multimedia traffic. So, when the internet was designed and evolved, in those days multimedia traffic was non-existent. It was essentially for data communication of emails and other information, not really for multimedia, at most some graphics. So, it was not really designed for multimedia traffic, and as we know, we have discussed two protocols, TCP and UDP. TCP includes connection establishment, error control, flow control, congestion control. We have seen all these things put lots of overhead and leads to delay and delay jitter, and as a consequence TCP is not suitable for real time multimedia traffic. On the other hand, UDP, which is connectionless protocol at the transport layer, can deliver real time data. However, as you know that UDP is unreliable, there is no error control facility. As a consequence, if error can be tolerated as with uncompressed audio and video, this UDP provides an alternative for multimedia communication. However, you will require a number of enhancements. You have to add some more functionalities and protocols to make the internet multimedia ready. Let us see what are the enhancements, what are the additional protocols that can be used to make the internet multimedia ready or multimedia enabled. First one is the multicasting. This is one very important requirement for multimedia. Multimedia is usually not between two persons, say it is not one to one, it is not for one to one communication, it is essentially for one to many. As a consequence, it is essential to have multicasting feature. Unfortunately, original internet protocol is a best effort unicast approach. Here there is no concept of multicasting. So, you have to add something on top of this, which is known as IP multicast, which is an extension to original IP protocol to support dynamic and distributed group membership, multiple group membership, and multiple send receive nodes. So, IP multicast protocol or feature has to be added on top of IP to make the internet protocol multimedia enabled. Another important feature function that is known as multicast backbone, which has evolved or has been developed to support multimedia to give you real time implementation of IP multicast. Let me give you an overview of what we really mean by multicast backbone. So, it can be considered as an internet radio or TV. You are already familiar with the broadcast radio and broadcast TV. There are radio stations and TV stations which continuously broadcast radio and TV signals, and with the help of our receivers and television sets, we can tune to one of the stations and get the radio and TV signals that we get through air. But here we would like to get through internet. How it is being done? An user will call up and ask a particular service, or he will want a particular movie or some particular type of music, and it will view uncompressed movies. And how it is being implemented? It is implemented in this way. It is a virtual overlay network on top of internet. So, the existing network is there, and on top of that there is a virtual overlay, and that is being shown in this diagram. It consists of multicast islands connected by tunnels. So, here is a multicast island. It can be a local area network as it is shown here, or it can be some other types of networks which we have already discussed, which have the multicasting facilities. So, each of these islands has got multicasting facilities in them. Then these islands are connected by what is known as tunnels with the help of routers, these M-bone routers, and through these routers they communicate with each other to give you the connection through the network. Then other enhancement required is UDP. UDP is more suitable for TCP for interactive traffic, but it requires services of RTP, a special type of protocol, real time transport protocol, an application protocol designed to handle real time traffic. It uses an even numbered UDP port, and the next number used as a companion protocol for real time control protocol. So, RTP used for data communication and RCTP used for control signal communication, and RTP provides end-to-end transport services to real time audio, video and simulation data. However, it does not give you QoS guarantee. Another important protocol that has been developed, that is known as RSVP, and it gives you a signaling protocol over IP, and it is runs over IP to provide the necessary quality of service, and it has got two components for flow specification. So, and actually you will require some flow based QoS model. So, two specifications are there. One is RSpec, which defines the resource specification required by the multimedia application, and TSpec, which defines the traffic characteristic of the flow. That means whether it is constant bit rate, variable bit rate and so on. Now, with the help of this RSVP protocol, the resources can be reserved along the path by using path messages and reservation messages, which is sent by the receivers, and on each node RSVP attempts to reserve resources to be able to provide the requested quality of service, and it can run over IPv4 and IPv6, and it is scalable and allows dynamic group membership and routing changes. Let us see how it really works. So, you see from the sender the path messages go to different receivers, then the reservation is done by different receivers by sending their requests. However, it also allows reservation merging. For example, from receiver 3 and 2, the bandwidth reservation is 3 and 2, which can be merged to have 3 megabits per second, and see this 3, and from receiver 2 it is 5 megabits seconds and merged to get 5 megabits per second bandwidth. So, 5 megabits per second is the merge bandwidth which is required by the sender. This is how the bandwidth can be reserved. Now, let us give you the review questions based on this lecture. First one is, what do you mean by multimedia? Second question is, what is SAS and what role it plays in multimedia communication? Third question is, explain the function of NPPs in multimedia communication. Fourth question is, distinguish between BRI and PRI of ISDN. Fifth question is, explain the role of RTP and RCTP. Now it is time to give you the answer to the questions of lecture number 35. First question was, what is the main function of UDP protocol? Answer is, UDP is responsible for differentiating among multiple sources and destination within one host. The multiplexing and demultiplexing operations are performed using port mechanism, which I have explained in detail in the last lecture, how multiplexing and demultiplexing is done. Second question was, why pseudo header is added in a UDP datagram? As you know, UDP header has got the information of source port, destination port, but it has got no information about the IP addresses. So a pseudo header is added, a 12-octet pseudo header is used for checksum computation by UDP. The purpose is to verify the UDP datagram has reached the correct destination, and destination addresses are essentially the source IP address and destination IP address. So this pseudo header is added and for computation of checksum in case of UDP. Third question was, how TCP establishes and terminates connection? Answer is, for connection establishment, TCP uses three-way handshaking protocol, as I have explained in detail, and for connection termination, four-way handshaking protocol is used for termination of connection in both directions. Fourth question was, what are the advantages of DNS, domain name system? As I mentioned, DNS allows meaningful high-level symbolic names instead of IP addresses, and which is more convenient for humans, and it uses hierarchical naming system, which has many advantages over flat addressing used earlier, and it is very efficient because of the use of distributed databases where authoritative records are stored. Last question was, explain how FTP works. FTP sets up, as I mentioned, two simultaneous connections, one for control and another for data. Control connection persists for the entire session. Data transfer connections and data transfer processes are created dynamically as and when required. The session is terminated when control connection disappears. This is shown in this diagram again, the control connection and data connection, and how the data transfer takes place from one place to another through internet. So with this, we come to the end of today's lecture, and in the next lecture we shall discuss about the compression techniques, which is indispensable for multimedia communication. Thank you.